Hello, in this example we are going to go through the mock-up version of the exam from the Tran book of the Certified SolidWorks Professional Challenge 3, which is really a bottom-up assembly with a part replacement and with creation of the sub-assemblies. So what we can do here, we can start by opening a part, which is the base from the Challenge 3. Subdirectory, not base B but base, and then we are going this base to convert into the main assembly. So when I click make assembly from parts, so this is the base that I'm going to use to make my robotic inspection arm. So what I'm going to do next, I will go make assembly from part. And that will transfer in default configuration, it will transfer my base. Going to click. And here is my base. The next step will be to readjust the center of gravity to correspond with the calculations that I want to have for the results. So according to the book, our center of gravity need to be moved along x-axis here, so and the x-axis need to be in the line with this edge. So what I'm going to do, I'm going to insert reference geometry with assembly, insert reference geometry. Let's see, where is the reference geometry here, and then it will be a coordinate system. And now I will choose this vertex, this here corner, and x-axis is collinear with this edge, with the y-axis going this direction. So I will need to change the axis by clicking on the y on the axis block and clicking on the edge which I want to be x, and then clicking on the opposite, which I want to be y. And the z will be vertical. So that's the right orientation of my coordinate system here. So I have inserted the new coordinate system, which I will use for any further things for the calculating the center of gravity, because the center of gravity answers will be used for answering your certified SolidWorks professional questions. Now we are going to insert the pivot arm. So we will just insert component, I will browse it, and it's called the pivot. Going to open it. I'm going to drop it somewhere here, for example, and now I'm going to mate it. I'm going to mate the cylindrical connection, the concentric, so between this cylindrical face and the inner cylindrical face. And this will be a concentric relationship. Face one of the pivot, and let's see what's happening there. So we will mate face of the base with the face one of the pivot as a concentric, and we will click OK. And the next thing that we are going to make, we are going to make the second mate will be a coincident of the bottom face of the circular boss with the top face of the support. So I'm going to mate the bottom face of this circular boss. The face, need to be careful here at choosing the face. That will be this face with the top face, and that mate will be a coincident. And the third mate, I will need to open the parametric trees of both pivot and the base. And I'm going to make the two planes to be coincidental. So the front plane of the pivot by pressing shift and clicking the front plane of the, clicking the front plane of the pivot of the base and front plane of the pivot. Control front plane and front plane, by clicking front plane. If I do the mate, as you can see, those two planes are now coplanar, which is a coincident mate. And those two components are now aligned. Now, that will be kind of the first question to answer, to measure the center of gravity of this object by going to the Evaluate, Tools, Evaluate, Mass Properties, and in a relationship to our new coordinate system, what is coordinate system 1, and center of gravity should be at x at minus 2.44 inches, y at 0.63, at z at 0.92. And that's correct answer. Now, in this you will be also asked to change the mate. Now, let's say that we want to have a different angle between our pivot front plane and the base front plane. Now they are coplanar, but let's say that we want to have an angle of 30 degrees. So how we will do that? We will do that by editing the mate. And you will do that by expanding the mate group at the bottom of the assembly tree by clicking on the left arrow. So I expand the mate group, and that will be my coincident 2. And I am going to click on the coincident 2, and I'm going to left click on the edit features, and I'm going to change it here from the coincident mate to the angular mate, and I'm going to choose that the angle between those two planes are 30 degrees. And let's see, and the orientation is correct. And as you can see, as I change here the degrees, the top pivot moves like 15. Let's go back to a 30. If it moves in the opposite direction, it means that you need to flip the dimension or flip the mate alignment. Okay? So click OK. And this will be probably your next question. So now let's evaluate the mass properties. Evaluate mass properties. And as you can see, the x minus 2.45, y 0.65, and z 0.92 inches in a relationship to our coordinate system 1 is correct answer. Now, we are going to insert other components. We are going to insert the arm, probe, piston, and piston housing. And we are going to mate them using really concentric mate and using the width mates. So, if I insert, and we are also need to create a sub-assembly. So, and when we create a sub-assembly, we will need to make the sub-assembly flexible. So let's first create the sub-assembly of the cylinder as a new assembly. So I'm going to start a file, new assembly. I'm going to create a sub-assembly which I will use to insert then in my main assembly. And that sub-assembly will consist of the files piston housing and piston. So I'm going to put as a base part piston housing. Just going to drop it, and I'm going to insert another part, piston. And only mate that this subassembly will have is the concentric mate between the outside of the piston and inside of the piston housing. And this now allows it to go in and out. We can also later on add additional mate there. We can drive that piston by actually changing the distances between by changing the distance in the pistons. So between the end of the cylinder and between the end of the cylinder and between the top surface of the cylinder, like we can create another mate here later on. So we can specify, like you may be asking a question in SolidWorks-Part III, what will center of gravity if the cylinder is in a position in a relationship to its base? So if the distance between two here is whatever X amount of inches. Okay, so I will save this assembly now. I will save this as a piston assembly. Now I will go back to my assembly 1, which I'm going to save as a robot, for example, robot probe. And I'm going to start inserting components. I'm going to start by inserting my piston assembly. I'm going to now right click on this piston assembly, and this need to be made flexible. And to make subassembly flexible is this last icon. And what it will do, if I click it make flexible, now any mates which are not completely mated, it will work. You see the assembly will now work. Okay, so now to place this piston assembly, we need to make two mates. First, we need to make this to be a concentric. So, but now how can we center this piston assembly? Here. We will use a new mate which we haven't used before, and that mate is called the width mate. And the width mate is used to position the object to be like symmetrically positioned in a center between the two different objects. So, width mate is under the pane of advanced mate. So if I click on the advanced mate and I click on a width, I need to choose the 4 parallel surfaces. I will choose the inner surface as a set of width, the inner surface of the larger piece, and then tab, I'm going to use the outer surfaces of the pins of our panel. And look what happened. It is perfectly centered. It is perfectly now centered. Now we will continue building our piece by adding other assembly features. By adding the other assembly features as per our instructional book. Now the next one that we need to do is the arm and probe. So I'm going to insert the arm. Arm piece, and I'm going to insert at the same time probe piece. Now we know that the probe goes concentric around the other end of the arm, so I'm going to choose the concentric mate with this face and with the inner face here, what will position it in the right position. And now how are we going to center it? We just did it. So who will tell me how we will center this? use the advanced mate, exactly, Josephine, click on the advanced mate, and then width, and then we will use the inner as a width, and tab outer faces of the other part. Okay, now this pin, this probe is flexible, and is there like as it should be. Now what else we need to do? We need now to make this whole thing to be flexible, and one of the way to do this, let's see what else is missing here. Do we have another pin piece or no? This thing will be again concentric with this thing here. So I'm going to make the concentric mate. I'm going to make a concentric mate of the pin face with the face here. And if I counter align it, there it is. And what else I will need to do here? I will need to make again tab and width. And to make that will be a mate, advanced mate, width mate, and the tab selection this time will be the inner faces of the circular boss of the arm, pardon, the width face, though the width is the inner faces of the circular boss of the arm, and the tab faces will be outer faces of the arm. And we are still not yet done, because we do have to do something with this guy here. And as you can see, this is an asymmetric part, so we need to look at which side it is oriented and how it is going to be concentric. And if we take a look at the book, this part, that is not really described fine, is oriented kind of in screen, so it's oriented there. So if I go to the standard mate and I use concentric mate, of this face and the inner face, and they are concentric. Now those two are connected. This will now fully define the kinematics of this mechanism, except that this one is free to flap, but however this will be kind of for the exam what they want you to have. You see, if I pull this cylinder, as I extend this cylinder, I can actually completely control. So by extending this, by actuating this cylinder, I can control this angle, and vice versa. Look, so it works like a mechanism. Now we need to constrain this mechanism. Yeah, so the current what we do not have here is the angle between the, we do not have specified angle between the arm and the probe. and we need to have this angle in order to work. Based on the drawing, it looks like a 45 degrees. So actually, we can specify that angle. And that angle will be another mate between the arm, and let's see which front. It will be between the top plane of the arm and between the control and top plane of the probe. And if I insert mate, and if I click on the angular, let's see if I put 30 degrees, for example. And we can play with the alignment versus counter alignment. 30 degrees. Okay, here it is 30 degrees, or 45 degrees looks like more. But it was more appropriate. And the other one is also not specified, but we can put something. In a real exam, they will all be specified so that the full assembly is constrained. And this one actually can be specified not only as angle, but usually in a real exam will be specified by the distance made between the cylinder and the bottom of the cylinder. Okay? Now let's do the replacement. Let's see the mechanism of the replacement of the part. To replace the base, we will replace the base part, which we have here. We can close all of the parts, which is a base part. We can replace the base part with a part which is called the base B. Right-click on it, and now we can go to the option of the replace part, and that option is all the way down, so we will need to go down. And there is a replace component. So if I click on a replace component, and configuration match name and reattach the mates. So with this one, I'm going to browse here, and the option to replace will be a base B. So I will click it on a base B, and you see it's a thinner piece that I'm trying to replace. I will click OK, but it does not have all the features of the base A. So I will click on Open. Okay. I will click OK. And as you can see, there are some missing entities that now SolidWorks asks us to reassign or to delete. There is a missing hole. But we can see, we can choose the replacement hole. We can choose the replacement hole. Face of the base one. Okay, so if I choose this here, if I go and if I choose the face of the base as the new base hole, and look what happened, because how the hole was created, now the base is counter aligned. I can click on a flip mate alignment, and here it is. And this is now accepted. And now we do have also that the second piece is missing also. So we will click on the next one, missing entity 2, and the top face that it is missing, we don't have that second circular bosses. We now have this face here, so I'm going to click on this face here, and this will bring us to a geometrically correct answer. And here is your piece now fully assembled when you click OK. Because we do not have correct informations for the angles here provided in the book, we can't really get the exact measurements, but we can assume that the angles are 180 degree, what will be the first angle. That's from the book. If I click to this one to be 180 degree. That's on your page. That's on your page, flip dimension, your page 2246, but we do not have an right informations for the angles between the arms and the probe. So let's see now in this configuration. We also, if we check the mass properties, evaluate, mass properties, rebuild. With the coordinate system 1, the mass property of the last question, x should be minus 0.29 and so on. So what we can do also, we can replace the coordinate system 1. We can replace the coordinate system 1. If we do it with a, if we do it with a default, it is a very close. So in a default, it is minus 0.21, and the answer correct is minus 0.22. Y is 1.09 versus 1.04, and Z is 0.00. So I messed up a little bit for some angles. So let's see if we can correct it fully, although we do not have information in a book. I believe if I do a cross section, and let's evaluate this distance here from the measure. Let's see what is the distance, minimum distance between this face and this face, 0.38 inches. How about if I put the mate inside my arm, if I put the mate here, and if I put the distance mate, and if I specify that the distance is 0.4 inch, and I choose this face versus this face. Well, we need to be, why it doesn't work? Because we need to be inside piston assembly to do this. So if we go back to my robot probe, I don't want that mate, so I will need, because the piston assembly is a sub-assembly, I need to create that mate here. I'm going to put the mate here of a distance and maybe 0.4 between these two surfaces. Rebuild, propagate, and now we go back to my main assembly and rebuild, and here is my little bit updated model, and let's check again the evaluate, and if I measure the mass properties, let's see if I was correct. Minus 0.21, 1.03 is 0.0 and 0.00, and it should be minus 0.22 and minus 1.09 and 0.0. So to do that, actually to do the other two corrections, what we will need to do, we will need to find actually exact distance, and to find the exact distance This is kind of a reverse than what will be on your exam. On your exam, everything will be specified. So, but let's see back if I just edit that mate in a piston assembly again. How about if I change it to 0.5 inch? No, that will be too much of the... Maybe 0.25? That kind of maybe look better. At the 0.25, as properties, rebuild. Exactly. So it was a 0.25. It was a 1/4 inch distance specification, which is by error missing from the book. So as you can see, it's minus 1.02, minus 0.22, y 1.08, and z is 0.00. So essentially, we specify this distance to be a 0.25, 1/4 of the inch. The assembly comes to its order as in a book. Sometimes you can fix the error in a book just by doing the experiment to find what the writer wanted to say. Okay, and that's another reason why I'm not into super big favor of ClickMonkey books, but this one is actually a good Click book. Okay, so well, this concludes our demonstrations. Essentially, your model will be very similar, and all the operations that you will have to do is just to assemble the parts that are given. You may be asked or you may not be asked to modify something, let's say to drill a hole or to do a very simple cutout on a base or to make some simple part like a pin. What we don't have here, we don't have, like we have a one missing pin. In a real exam, you may be asked to like make just a simple pin, like to make a one part. And that will be the last of the SolidWorks exams of Certified SolidWorks Professional Mechanical Designer exams. So, to be successful here, what we need to do, we need really to read carefully question, need to choose the right coordinate system, we need to choose the right coordinate systems, we need to choose the right units and right number of decimal points, and we need to be sure that we use the flexible sub-assemblies, like you will have to do the sub-assembly, and if it is not flexible, that thing will not work. And we need to know how the width mate and how the symmetry mate works. Okay, so well, this concludes this video.